Hello, my name is Martin Fawn, and I am a solutions architect with CalLogic Software. In this video demonstration, we'll be talking about Oracle Backup and Restore using CalLogic Software's ECX platform. We'll be using an Oracle database that resides on a Pure storage LUN attached to a Linux server. Using direct integration into the server and storage infrastructure, ECX can discover the storage LUNs on which Oracle resides, in this case, Pure Storage. Invoke operations like snapshot and replication to take an application consistent copy of that database and move it throughout the environment while cataloging the location of all the copies. In addition, it can perform operations to further mask that copy for DevOps use cases at the primary or replica location and spin up any copy either to the original or alternate database instance for test dev or production recoveries within a matter of minutes. So with that said, let's go ahead and jump right into the demonstration. For this demonstration, I'll be using an Oracle database that resides on Pure attached to a Linux server. Here I have a PuTTY window open to that Linux server, in which case you can see as I grep for my Oracle Process Monitor that this database name is called psalesdb. Now, within my Pure Storage interface, I can see a volume LUN has been set up for my database files as well as my log files. Now let's jump to the ECX console. So ECX is actually a software appliance. It deploys as an OVA file which lays down its own base Linux operating system from which you can just access through any web browser. Here I can log in as my local admin user. Alternatively, I can set up additional sub-administrators to log in. And the first thing I want to do is configure my Oracle database server within my enterprise. So for that, I'll just click on my Configure tab and register a new application server of type Oracle by right-clicking and adding an Oracle database instance. Now, all I really need to add that Oracle database instance is just a host name and an IP address. In the back end, we're performing a dynamic code injection at runtime to interoperate with that database server. And we can do so for both Oracle physical or virtual machines, as well as use key files or passwords for credentials. So I can log in with my Oracle database admin user as long as that user has sufficient system privileges in order to interoperate with that database. In this case, you can see here as I expand the application server tree that I have several Oracle database servers already scanned in. The one that we will be testing with is this psdemo or ASM iSCSI instance. By default, after you add your Oracle database server, we'll add it to an inventory policy, in which case we'll look up all the database instances and databases that live on that server, and as well as detect the underlying storage devices that make up that database. So for example, we would detect Pure as the underlying database LUN. Now that I have my server registered, let's jump to jobs and define a backup job. So in the jobs tab is where I would define my Oracle backup and restore. And I can do that through this section of the tree here just by simply right-clicking. I've already performed the inventory. By default, after registering the server, I've done an inventory of that database server. So now I can just simply perform a backup by selecting backup from the context menu. And drilling down into the different sites that I have out there, I can see that there are multiple instances that were detected by the inventory for this server, one running Oracle 11 and the other one on Oracle 12, which is where my psales database resides. And by selecting that as my database source, I can now define my backup job. Alternatively, if I look at some of these other database instances, you'll notice that some of them might not have checkboxes next to them. In these cases, what we found is that some of these databases did not reside on supported storage platforms like Pure. Okay, so we're just signifying that we cannot perform copy automation on these databases. But psalesdb, since it does reside on Pure, allows me to perform a check mark next to it, and that'll be the source for my backup job. I'll apply to this my SLA policy. So this is kind of how often I want to snapshot, how often I want to replicate to another flash array. In this case, I'll keep it simple and just leave everything in place. Every 3 days, schedule a silver SLA to snapshot that database in place and provide my backup job with a name. So after defining my backup job, I can just simply create that job link there. But we're going to check out some of these other options down here. Advanced allows me to perform other operations and interoperate with some of the Oracle tools running on that server. For example, I can catalog the job within RMAN itself to appease my Oracle DBAs that are still accustomed to doing their backups or restores through RMAN. In this case, by cataloging the entry within RMAN, I'm able to mount a copy of the snapshot back to the database server and allow my DBAs to perform their traditional levels of recovery through RMAN. The second tab is the log backup tab. So log backup allows me to send my archive logs to another mount point. In this case, I can choose a mount point for each database that I'll be backing up, or use a universal destination directory for that database. And what this means is that by allowing me to back up those archive logs to that mount point, which of course would need to reside on peer storage as well, I can snapshot the database as well as the archive logs and do a point-in-time restore, orchestrate a point-in-time restore directly from the ECX console. Of course, your database does need to be in archive log mode in order for this to occur. Finally, the last feature that I want to discuss in this is data masking. So data masking allows for me to set up a schedule where I can mount my database copies and run a masking script against them. So I can drill down into the instance of my source here, select individual databases that I would like to mask. If I were doing a in-place snapshot or replication within the same SLA policy, I can choose which copy I want to be masked, either the mirror or the primary storage snapshot. And all I would do is select the database server instance which I would want to mount this production copy to. So I can mount that production copy back to the original server or a different instance entirely and run a masking script against it on a monthly basis. So I'd schedule my activation time and trigger and retention period all on the screen as well. Having a mask copy of the database allows me to keep two separate copies, one production copy and one mask copy, where I can obfuscate proprietary information, confidential information like social security numbers, credit card numbers, salaries, etc. Okay, so with that said, my backup job has been defined. I can go ahead and click create job, and you can see here that I already have a backup job already defined for that physical server instance. And this is a backup job that I recently ran, and you can see here that it ran at about 2 minutes and 20 seconds or so. But what the ECX framework is doing here is it's simply resolving the databases that it's discovered. So finding those databases to protect, resolving them down to the underlying storage LUNs on which those database resides, performing any pre or postscript operations to quiesce that database, and then finally using storage level snapshots to take copies of those databases. So very quickly you can see here all that's happening in terms of our discovery and backup of this psales DB. We discover the psales database, we resolve the database down to pure storage disk. In this case, it resolves down to those iSCSI data and logs volume on my pure storage, and we take a snapshot of that database. And you can see here that these snapshots were taken at around 8:47, 8:46 or so, and we should have corresponding snapshot entries in those database volumes, as you can see here. So these are the snapshots that we're going to be using for recovery. Performing a recovery is just as simple as selecting the snapshot that you want to recover and then choosing the destination that you want to recover to. So I will right click on my Oracle object. I'm going to select restore, and you can see here some different templates for performing restore. I can either do an instant disk restore, in which I can mount the Oracle backup archives in order to perform an RMAN recovery, or if I want to automate the entire process of recovering the database, I can do an instant database restore. And DevOps restore is very similar to an instant database restore, only that it uses the mass copies if I set up a masking workflow as part of my job policy. In this case, I'll choose to do an instant database recovery, drill down into the Oracle instances that I've protected, and select the database that I want to recover. In this case, I want to recover psalesdb. The ECX catalog knows exactly where all my copies are. So it shows my copies as being all in place at my New York site, and it can show me the different versions of the copies that I have out there. So these should all correspond with the pure storage snapshots that I've been taking. You can see here April 24th through the April 9th, and jumping back to the pure storage snapshot, you can actually see those corresponding dates matched there. So by default, I can use the latest version of that snapshot, which I can schedule a policy or restore to run on a daily basis, or perform an even more granular recovery using a point-in-time restore. In which case, when I run the job, it'll ask me to select the date and time at which I want to recover the database. At which point, when it performs its recovery, it'll mount the production copy of that database and then play through any of the archive logs that have been captured as part of that log backup operation. Finally, the destination, where I want to recover this database instance to. So in this case, I'm going to recover back to the original server instance, or I can recover to an alternate instance here. I can select the destination or database name that I want to recover to. In this case, I will call this database DSalesDemo. SalesDB, and provide that job with a name, which will activate the create job link. So you can see here that I actually have a Oracle restore job already created. I'm going to go ahead and run this, and then fast forward through the video as this is running. So you can see with the automation processes that are occurring on the back end, we're just loading the information that we have in the catalog, ensuring how that Oracle database server can connect to that peer storage array, and just simply attaching new temporary LUNs that are going to be created to that server. I'm going to go ahead and let this run, and then we'll be back in a couple minutes. Okay, so we are back, and you can see here that my Oracle SalesDB job is completed. Duration was about 4 minutes and 40 seconds, but all we did to restore that database was just simply present that snapshot copy up as a new LUN and recover the databases as that new name on our PS demo or ASM iSCSI server. Now you can see that these LUNs are actually going to be new volume, temporary volume objects connected to my peer storage array. So if I perform a refresh against any volume objects, you can actually see two new LUN objects presented to that Oracle ASM iSCSI server, which represent my data and logs folder, as well as I should be able to see a new database on my Linux server. So I'll just go ahead and log back in and perform my PS against PMON, and you can actually see a new database instance called DSalesDB running on that server. Now jumping back to my ECX GUI, what I should see in my Jobs tab is a status of resource active. So as I ran this database restore, what it did was present snapshots up as temporary storage mount points to create this database. And now that resource is being specified as being active on my database server. And the reason why it's active is because it's waiting for me to perform an operation against it. Do I want to make this session or this database permanent, or do I just simply want to cancel the restore? So by clicking on cancel restore, it's going to connect to my Linux server, database server, dismount any Oracle databases, or dismount that database DSalesDB that I just brought up. So by running that PS command, I should see that database going down, and it is going down. And once it's down, I should be able to verify against my peer storage volumes, that storage disk or those storage volume LUNs have disappeared. And you can see here that the temporary storage volumes that were created as part of the orchestration process of that restore have indeed disappeared. So I hope you enjoyed this video on Oracle Backup and Restore using Catalogic Software's ECX platform on peer storage. If you have any questions, feel free to visit our website at www.catalogicsoftware.com. Thank you and have a nice day.